Okay, so today we're going to talk about acids and bases. And the first thing I want to do when we're talking about acids and bases is I want to introduce you to the proton, which is H positive. So since it's positive, that means it's an ion. And H positive is also called a proton, and I'll show you why. So if we look at the periodic table, here is hydrogen right here. And hydrogen has, because it's atomic number 1, it has 1 proton. And because it has 1 proton, that means it also has 1 electron. And because it has 1 electron, it has 1 neutron. So that's H, hydrogen. But if you take away the electron, that's going to take away 1 negative charge, leaving just the 1 positive charge for a proton, leaving it a hydrogen plus, H plus. So that's why they call H plus a proton, when it's actually just a hydrogen ion. And remember, an ion just means it has a charge. So of course, this would be an ion, a hydrogen ion, because it has this positive charge right here. So back to acids and bases. This hydrogen plus is also called a proton, because it's a hydrogen minus the electron. And an electron is a -1, so an H minus a -1 equals an H positive. Now this H positive comes into play because it's going to be at the beginning of every single acid that you have to study. Like here's hydrochloric acid, see the beginning of it begins with an H. And if you break this up into its ions, the hydrogen becomes the hydrogen ion, and the chlorine becomes the chloride ion. And that's how they fit together. So hydrogen plus the chloride negative ion. If you add these two together, the plus and the minus, that makes 0. So hydrochloric acid. Now, so this H plus is what makes an acid an acid. It's going to be at the beginning of all of your acids. Now, you should, by now, have memorized these strong acids. This was a memorization assignment in your chemistry class. You should have this memorized, the strong and the weak acids. But the trick is that if you just memorize these strong acids, then you'll know that all the other acids are going to be weak. So you don't really have to memorize the weak acids at all. You only have to memorize these strong acids, which there's 7 of them. 7 strong acids. And if you notice, at the beginning of every single acid is a hydrogen. Now a base, you should also have all these strong bases memorized. They give you a list of bases to memorize, but the trick is that you only have to memorize the strong ones, the strong bases, because all the other bases are weak. So if you just memorize these 8 strong bases, then you'll know that the other bases are weak. And in these bases, if you notice, these don't begin with H because they're not acids, but what they all have in common are these OHs. OH, OH, OH. And an OH negative, and it's got a negative charge to it, so that means it's an ion. This is called hydroxide. And so that is what is the component in strong bases, is hydroxide. Now, what makes acids and bases strong? Why are these particular acids and these particular bases called strong acids and bases as opposed to the other ones being weak? Well, when you put them in water, in H2O, they completely break apart into their ions. And that's what makes them strong. So if you have hydrochloric acid and you put it in water, that is going to yield hydronium and a chloride ion, because when you take this H that makes the acid in hydrochloric acid and you add it to the water, the H2O, you end up getting H3O because there's that extra H in there. And then the chloride that's left over after you take the H and put it in with the water, the chloride ends up as its own ion. So this is what makes hydrochloric acid strong, because when you put it into water, it breaks up completely into its own ions. The acid hydrogen, the hydrogen proton, joins the water and makes hydronium, H3O, and then the chloride becomes its own ion, which is negative. Oh, and the hydronium is positive. It keeps that positivity. Now let's go into this a little bit more. So we have hydrochloric acid plus water yields hydronium plus the chloride ion. So if you look at the hydrochloric acid, if you break this up into its own individual ions, and remember, an ion means it has a charge. So this H is going to turn into an H positive, which is a proton, and that's what makes things acid. And then this chloride or chlorine turns into chloride, a negative ion, because the H has to be positive and the chloride has to be negative in order for the positive and the negative to come together and equal 0, because they should balance each other out. So when you break apart hydrochloric acid, it breaks up into its own ions. And an ion means a charge, positive or negative. So we have a positively charged hydrogen and a negatively charged chloride. So that's going to be reflected in the right side of the yield arrow. This H, one of these H's out of the H3 is that H plus. So here's the plus from that H. And then the chloride is going to have a negative charge to it, and that's going to be all on its own. So that means this is strong. Now for bases, bases are going to do the same thing. Let's take the base lithium hydroxide. Okay, lithium is its own element, and then there is hydroxide, which is an ion, which is negative. And if you look on the periodic table, well, here's the O right here for hydroxide. And the O, here's this column is going to have a -1, this column is going to be -2. So the O is going to have a -2 charge by itself as oxide. But then you take the H, which is a positive ion, so the H positive ion plus the O with a -2 charge is going to equal OH with 1 negative charge. And that's because the +1 and the -2 is going to equal a -1. So that's going to equal hydroxide, which is an ion. And remember, ion means it has a charge to it. So here's the charge, here's the negative charge, and this is going to be a base, hydroxide. Now back to the strong acids. If you take any one of these strong acids, you can break them up into their own separate ions. So for hydrochloric acid right here, this is going to break up into an H+, and this is going to break up into a chloride -1. If you take the hydrobromic acid, HBr, this H is going to break up, it's also called dissociate, or dissociate, and that just means break apart. And this Br, the bromine, is going to break apart from the HBr, and the bromine is going to have a negative charge to it. Now let's look at HI, Hydroiotic Acid. HI. The H, of course, is going to break apart and have a +1 to it. And the I is going to break apart and turn into iodide with a negative charge to it. So as you can see, all of these acids, they're going to break apart. The HNO3, the H is going to break apart into the H positive, and the NO3 is going to stay together as its own ion, NO3, and that's going to have a negative charge to it. So as you can see, all of these will break apart into their own ions. HClO3, chloric acid, the H is going to break apart into the H positive, and the ClO3 remains its own ion, and that's going to have a negative charge to it. So as you can see, all of these acids can break up into their own individual ions. So when does this happen? When do these acids break apart into their own ions? Well, it's when you add water to it. So let's say you have hydrochloric acid. And remember, if these break apart, you end up getting an H positive and a Cl negative. Well, if you take the HCl, hydrochloric acid, and you add it to water, which is H2O, this H breaks apart and turns into the H positive, and that combines with the H2O, which is going to equal H3O, positive because it's taking the extra H, and adding it to that 2 H's to make 3 H's. But remember, this H, this hydrogen has broken apart. It's an ion, and it has this positive charge. So that positive charge also has to be carried over. So this is called hydronium. And then what's left? Well, what's left is this chlorine. And when the chlorine breaks apart, it breaks apart as an ion, which is chloride. And so we're going to put this over here, plus chloride. So see, when you add HCl to water, you end up getting hydronium and chloride. And see, these two are ions because they have a charge. So this means that it's going to be a strong acid. But you really can't tell by just looking at the formula if it's going to be strong or not. That has to do with figuring out the pH of it. So that's why you need to memorize. These strong acids that was given to you at the beginning of the semester. And then you can just go ahead and assume if it's not on your strong acids list, then it's a weak acid. So what is a weak acid? A weak acid, instead of it breaking up into its own separate ions, it doesn't totally break apart. So what happens with a weak acid, so for an instance, HClO is going to be a weak acid. And how do we know it's an acid? Because it starts with that H. So that means it's an acid. So this is called hypochlorous acid. Now what happens when this separates, this hypochlorous acid separates? The H comes out and it turns into the H positive like normal. It turns into a hydrogen ion. And then this, the ClO, turns into its own ion, which is negative. But when you go to add them to water, what happens is, okay, so this H joins the water and it turns into H3O plus, and then you end up having the chlorous ion left over. But these guys don't like to be on their own. So they just keep trying to go back and recombine with the hydronium in order to go back and get water and hypochlorous acid. Which is why when you write a weak acid, you write it with 2 arrows. You write one arrow one way and the other arrow the other way to show that this keeps trying to go back and reform into the hypochlorous acid. So that means if it's a strong acid, you have one yield arrow going to the right. If it's a weak acid, it's still the same formula, but you have an arrow going to the right and an arrow going to the left to show that they go back and forth and they reform the original acid. Now another thing you need to know about acids is what's called the Bronsted Lowry. And That means that when you take something like hypochlorous acid and you add it to water, and it makes hydronium plus chlorine or chloride ion. This is strong because it breaks up into its own individual ions completely, and there's only one arrow going to the right because it means it's broken up completely into its ions and they're not trying to get back together. If you notice where the H goes in the acid H in the hydrochloric acid, this H joins with the water. So one of these H's out of the three, and this little positive sign, is part of this H3O. So this used to be H2O, and then we added an H plus and ended up getting an H3O plus. So this received the H, the proton that's in the acid. Now this chlorine or chloride at the end here that broke apart, this was originally part of the hydrochloric acid, but it lost that H, and so it's all by its lonesome over here. So it lost the H, so it's no longer an acid. Now when you're doing these formulas and after the yield sign you end up with the hydronium or whatever that received the H, which is an acid, the one that received the H, the one that received the acid, is called the conjugate acid. And the thing that lost the acid, the Cl, the chloride that lost that proton, that H positive, it lost the acid, that is the conjugate base, because it's no longer an acid. So pretty much when you write any formula, anytime you write any kind of a formula where an acid shifted around, where an H positive is shifted around, on the left side of the yield arrow are the acids and bases, and on the right side of the yield arrow are the conjugates. So whatever received the H positive that was making it an acid, that's called the conjugate acid. Whatever lost the acid, whatever lost the H, so it's no longer an acid, that's called the conjugate base.